Data Analysis by Python, Part 1.
In this section, we will help you learn about data analysis and exploration as the first thing that you start doing in data science. And end of this lecture, we will talk to you about, you will learn about how to conduct a exploratory data analysis called EDA, basically to understand patterns, trends, and anomalies in the data, right? Ready? Good. So, what do you think? How would you conduct exploratory data analysis? How would you do the EDA? See, EDA is an important step, a crucial step in the data analysis process, and that allows you to understand the structure, relationship, and potential issues with your data sets. Important. How is your data structured? What are the relationship between different parts of the data or features or variables as we call it? And what are the possible issues within your data set? So that's the starting point. And how can you do that? Let's look at some practical steps that you can take to see how to conduct the EDA. And in these slides that we go forward, we will discuss the steps and also illustrate the codes that you can use if you know understand coding, or to at least give you some idea of the kind of codes you will need to write in Python. Loading your data set into the data analysis environment, such as Python, using libraries like Pandas or R. So that's your working tool, Python libraries like Pandas and R. And in that you load your data set. And at the same time, what you do is you familiarize yourself with the structure and the types of variables in this data set. What are the different types of data sets, variables in the data sets, or the features in the data set that you have? And then you generate summary from numeric variables that includes mean, median, standard deviation, minimum, maximum, and quartiles. These are all statistical terms that you must be familiar with, or you should become familiar with. And this provides a quick overview of the central tendency and spread of the data. And here you see an illustrative code that has been written in Python to generate that summary statistics. Then what you do is you handle missing data. How do you handle missing data? You identify the missing values, and by again writing a code in Python that you see here as illustrated here. And in this, so you also consider imputing, calculating, inferring, removing the missing values, and other strategies based on the nature and amount of missing data. So that's how you handle the missing data. Third thing that you start doing is the analysis, in which the first step, one possible, is to do a univariate analysis. You explore the individual variables to understand the distributions. And how can you do that? You have two possible two codes written in Python to do that. First one is about, and then you create histograms for numeric values and bar plots for categorical variables. So first one is a histogram for numerical variables that you can create using Python, and second one is about a bar plot. So that's how you do the univariate analysis, and that's where you start understanding the data. Second thing that you can do is to do bivariate analysis, and then there you start investigating relationship between the pair of variables. So there's a lot of data that you need to play with, and you must love playing with data if you want to become a data scientist, because you need to do that. And here you can use scatter plots for numeric relationships, and stacked bar plots or heat maps for categorical numerical relationship. And here it is example for a numeric relationship in Python that you can use, that a code that you can use to do this bivariate analysis. Also, you can do multivariate analysis, and you may need to do that multivariate. And there you extend the analysis to multiple variables simultaneously, and utilize techniques like pair plots, as you see here in the code, correlation matrices, and parallel coordinates plots. So these are various techniques that you can use in Python to do the multivariate analysis. Then you do what is called outlier detection, where you handle and identify and handle outliers using visualizations like box plots, scatter plots, and statistical method like z-scores, IQRs. And here you see an example in Python of figuring out how to write a code for box plot for outlier detection. So you see here, Python is a critical language for you to become a data scientist, because you will be using Python every now and then to fetch data, to understand data, to plot data, to analyze data. Then you can do the time series analysis. If you are working with time series data, you can visualize trends, seasonality, and autocorrelation. And again, you see a code written in Python to do this time series plot. Also, you can detect anomalies. You can implement anomaly detection techniques such as clustering or statistical method to identify unusual patterns and outliers. Here you see a method called the k-mean classification that is used to detect the anomalies that you see. Anomalies are outliers, right? That do not belong to the data as such. Then consider transforming variables like log transformation, a plain data that you see on the left side which doesn't represent any significant trend or pattern. If you convert into log transformation, the log values of those values, you can see a nice central tendency, a histogram coming up. And this makes the data more suitable for analysis. So data transformation is also possible.
Thanks for watching video. Don't forget to like, subscribe, and hit the bell icon for more interesting upcoming videos.
See you next time.